Video 3 examples for you. We are looking for the open intervals where the function is increasing and decreasing and locating relative extrema. So when we look at our example, x squared minus 3x minus 4 divided by x minus 2, we have to be aware of the fact that our domain does not include 2. X cannot equal 2. So that means 2 could never be an extrema of any kind. It still can be a critical point, but it's never going to grow up to be a big and strong relative min or relative max. Okay, we need to find our first derivative because we need to find those critical points, because the critical points are where we could be changing from increasing, decreasing, etc. When we take the derivative of the numerator, that's going to be 2x minus 3 times the denominator as is, x minus 2, minus the derivative of the bottom, which is 1, times the top as is. All over the bottom squared. X minus 2. Now we do have to do some simplification, so if we FOIL that out, distribute our negative, we're going to end up with x squared minus 4x plus 10, still all over our x minus 2 quantity squared. I'm going to set each of these equal to 0. I want to know where my derivative is equal to 0. Well, that's where the numerator is going to equal 0. If you use the quadratic formula, that doesn't equal 0 anywhere, so that doesn't give me any critical points. Where the derivative is undefined, that's where the denominator equals 0. And that's going to be at x equals 2. So our only critical point is at x equals 2. When I make up my little sign chart here, this is my first derivative. If I put 2 on there, I'm going to end up with a positive value and positive value on both sides, because that is a 2 power on that factor, so it's not going to alternate. So what that tells me is that I'm increasing everywhere, but I have to say it using the wonderful sentences. So this is what is going to count as our justification. My derivative is greater than 0 from negative infinity to 2 and from 2 to positive infinity. So our original function is increasing from negative infinity to 2 and 2 to positive infinity. We aren't decreasing anywhere. So if we don't switch from increasing to decreasing or decreasing to increasing, we don't have a relative extrema. So since f is only increasing, there are no relative extrema. And we can just blanket all of that in there. So just to recap, when you're looking at your original function, always look at the domain to see if these critical points can grow up to be relative extrema. Because remember, to be a critical point, you just have to be where the derivative is equal to 0 or undefined. To be upgraded to a relative extrema, you have to be a point on the graph, and you have to be there has to be a sign change. Okay, let's look at our next example. Oh, a trig function. We love ourselves some trig functions. We are going to take the derivative of sine of x cosine of x. We have to do a product rule. The derivative of sine is cosine times cosine as is, plus the derivative of cosine, which is negative sine, times sine as is. So I took the derivative of the first times the second as is, plus the derivative of the second times the first as is. I'm going to clean that up a little bit. So I've got cosine squared minus sine squared. Now, depending upon how you want to do this, we are finding the critical points. Excuse me. The critical points, so you can solve it as it is now And note that if you take the sine squared to the other side, you square root both sides, you're looking where sine is equal to positive and negative cosine. That might be a little tricky. I noticed that cosine squared minus sine squared is my double angle formula for cosine of 2x. Then I know I can graph it. So if I just make a little picture, and once again, this is the picture for my derivative. When I look at my cosine, if I were to graph this little guy, I know my amplitude is 1. My period is going to be pi. So that means my critical points, I'm going to have pi over 4, pi over 2, 3 pi over 4, and pi. And then I keep going, so I have my 5 pi over 4. Let's try that. 3 pi over 2. 7 pi over 4. And then 2 pi. I know I have to keep going because of this right here. I know that's going to affect what happens down here. Okay? So now, when I go to graph this, I know that cosine starts up, and then we're going to go down, 0, back up, 0. So looking at the way my graph looks, and it is super, see, I am setting the bar so low for you to draw these correctly. Points are going to be at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Without the use of a calculator, it just makes it easier if I sketch a little graph. Also, if I sketch a little graph, this takes the place of my sign chart that I usually do. For instance, looking at this little sign chart right here that we draw, that's our picture right here. So in between 0 and pi over 4, I'm above the axis, so that's positive. In between here, I'm below the axis, so I'm negative. Above, so I'm positive. Below, so I'm negative. Above, so I'm positive. So drawing this little picture not only helps me find those critical points where my derivative is equal to 0, it also helps me find those positive and negative intervals. Now I just need to write it out. So my derivative is greater than 0 from 0 to pi over 4 and 3 pi over 4 to 5 pi over 4 and 7 pi over 4 to 2 pi. So f is increasing on those same intervals. And I know you really do want to put ditto marks, not write them again, but we have to. Remember, we're practicing for the big test, and we want all of those points. Okay, so our first derivative is less than 0 on those other intervals from pi over 4 to 3 pi over 4, 5 pi over 4 to 7 pi over 4. So f is decreasing from, we write those intervals. Even as much as we have to write, it's only 7 sentences. It's not a term paper. We'll be okay. Now we get to do our increasing, or our relative extrema sentences. Since f changes from increasing to decreasing at, so we are increasing to decreasing at pi over 4. We are increasing to decreasing at 5 pi over 4. So these points are relative maxes. We get to write out that next sentence. Since f changes from decreasing to increasing at x equals the other 2 points, our 3 pi over 4 and 7 pi over 4. So x equals 3 pi over 4 and 7 pi over 4 are relative mins. I know, once again, you hate writing the sentences, but we need to be talking about the fact that first derivatives are positive means that our function's increasing. First derivative negative, it means our function's decreasing. When our function changes from increasing to decreasing, that's a relative max. Remember, you can also say that the derivative changes from positive to negative. That also tells us we have a relative max. That last example we're going to do when we get into class, so I will see you then.